Okay, let's get started. I think it's time. Let's get started. So today is the day one. So we'll try to cover like what are large language models, like have a basic understanding of what they do. What is the history or the background of? I want to give you some context around like how did large language models come up? What was there before it, and all those type. What are the different types of large language models, like base models, chat models, reasoning models, and stuff? What are closed source models and what are open source models? How do we run these open source models in our local environment? And then we'll see how to integrate or call an LLM via an API or an SDK. So what this will help you overall is it will help you understand the AI landscape around the models, right? What are different kinds of models? What are the different family of models? And basic understanding around the model landscape. Okay. So let's get started. Okay. So basically, we will start with, like I said, like what are like we always hear this term, right? GPT-4, GPT-5, or we might heard about Claude a lot. It's getting very famous these days. Gemini from Google, right? And Llama from Meta. So what are basically these things? They are all called as large language models. In the ML world, they are called large language models. Okay. So GPT is an implementation of a large language model that is by a company, OpenAI. But the overall concept is they are called as large language models in the machine learning world. Yeah. Okay. So why they are called as large? Like what's the reasoning behind calling them as large? Okay. One is like they are trained on a very huge amount of data. You can call it as the whole of internet. So when you create a model, right, what happens is first you need to train it. So what I mean is like when you need to train it, right, it's trained on all the articles available on the internet. There's obviously a process which goes behind, but that is where large comes in because it's trained on large data. The second concept why it is called large is because of the parameters that it has. Like GPT-4 has 1.76 trillion parameters. We'll look into what are parameters in details, but on a high level, what parameters mean is like they are like knobs, right? When you change the parameters, it can change the output of the model. So when you read about any model, right, there this term parameter will always come in. Like some are 12 billion parameters, 20 billion parameters. So models have different parameters. Parameters mean some knobs that you can adjust so that to get specific results. Okay. Now, what are large language models? Okay. When I say large language models are also like a computer program. At the end of the day, everything is a computer program itself, but they are different, right? They are different from the traditional programming that we do. There's no like if and else conditions that we write in the program. When I type in a question into GPT, it's not like going and looking into a database and answering me back. So it's not if else condition, it's not database lookup. It's based on pure mathematics and statistics. Okay, we'll deep dive into how is it pure maths and statistics. But I just wanted to give a high level overview that it's not if else or this database lookup or traditional programming that we do. Okay. Now let's take an example of like what is a model. So think of the model as a program itself. Okay. Now we take the internet, all the data available on the internet, we train the model on this particular data set. Okay. Then we get then what we do is we fine tune the model. Okay. Fine tune meaning, what does it mean is like when you train the data, like when you take a model and train it on the data on the web, right? It just learns how to predict the next sentence when you type in a question. But fine tuning is required to like when we use chat interfaces or GPT, right? We type in a question and we get in an answer, right? In a form of a paragraph, not a filling the blank kind of thing. So fine tuning takes care of like the word says, right? Fine tuning the model to get a specific set of response. Okay. And when fine tuning is done, the final model is ready. And then we as a users go into the chat GPT interface and we query this particular model and we get back the response. So from data on the web till this part, right? The final model creation, this is called training of the model. Okay. So this is a separate thing. And then once the model is completely trained, right, then it's released into the public. And then users like you and me can go in and query the model. So this phase, right, querying the model is called inference. So this is the technical term which might be used, right? Why I'm telling you all this is like very high level, like what is a model, how is it trained, and what do we do today? And these are technical terms which will come along as we move ahead. Okay. So any questions till this part, or are we good?
Yeah, clear.
Okay, let's move on to the next topic. So, like I said, right? So one thing which so we often see this chat GPT and all, right, as a magic, right? I'm typing any question and it's giving me answers and all. How is it doing it, right? Is it some magic or something? But I want to, I will tell you about two concepts now. So try to like internalize these concepts so that you develop a mental model of how these things actually work. Okay. So what happens when I go to ChatGPT? When I type in a question, I get an answer in the paragraph in the form of a paragraph. But what happens internally, right? So let's say if you type in a question, why is the sky blue, right? So what the model does is for it, it is nothing but a fill in the blank. Okay. So when you type in the sky is blue, for the model will look it as like this, like why is the sky blue? Fill in the blank, which means like just come up with the next word which should come after it. Okay. So I'll take an whole example and answer this and show you how LLM predicts or like answers the question. The only job that LLM does is, or the core mechanics behind is, you just need to predict the next word or the next token. Okay. So let's take an example. You type in the question, why is the sky blue? So now what the model will do is take this as input. Why is the sky blue? Now the model, when it answers, right, it will take this as input and predict the next word, which is the, right? Now it will take into account this whole thing. Why is the sky blue? And it will predict the next word, which might be sky, right? Then what it will do is it will take why is the sky blue, right? The previous words that it predicted, the sky, and then predict the next word, the sky is blue. So on and so forth. So what it's doing is taking in the question, predicting the next word, again taking in the question, predicting the next word, so on and so forth, till it comes to the point where it answers the question, the sky is blue because of scattering of sunlight in the atmosphere. So it will come up with this whole paragraph, but the core mechanics is it's like just predicting the next sentence. I'm just giving you this overview so that you develop a mental model. It will come in handy when we go into the architecture and see the math, how it's predicting the next word. Okay. And how does we directly see this answer, right? So it's so fast that you will not see this, the sky, because of all these things, you will not see, you will directly see the answer. But underlying, the model is behaving in this particular way, right? Now, this all is there's no intelligence involved over here. It's pure math. Let me tell you how. Okay. So let's take an example that like I said, right, in my previous slide, I said like we are training the model on the data from the web, right? So if and what I'm saying now is the system is not intelligent. It's like math driven. Okay. So let's say in my training data, what happens is like when I when I ingest the articles from the internet, or when I train my model on the data on the internet, I will come across various articles which have some information about the sky. Let's consider 4 articles which will have information about the sky. First is the sky is blue, right? Another article which has this information about the sky: on a clear day, the sky is blue. Another article might have information which is like this: when I look up the sky is blue, right? The grass is green and the sky is blue. So this was my training data. Okay. So now when I type in the sky is, right, so it will treat it as a blank. And you can see that based on my training data, right, the training data which I received over here, every time I type in the word sky, it is preceded by the word blue. Okay, over here. So what it will do is it will just see the probability of the word blue coming after the sentence the sky is, and it will just there's 100% probability that blue should come after the word the sky is. So it will say the sky is blue. Okay. To make it more clear, right? Let's say if I change my training data, somehow a hypothetical scenario that I go in and change all the articles on the internet, and I make it the sky is yellow. On a clear day, the sky is yellow. When I look up the sky is yellow. The grass is green and the sky is yellow. So what it will do is now when I go in and ask that question, right, to the LLM, it will start saying the sky is yellow. Okay. So this is what is interesting. So the point that I wanted to mention over here is we think of LLMs as there is some understanding of the world. They are thinking and all those things, right? But it's not at all thinking and all those things. Whatever data it is trained on, it will give you that particular output. Okay. So that is what the whole point was. And using mathematics, it will predict that particular data. And we'll go into the whole mechanics or the mathematics, how will it come up with. But the core concept you understood, right? It will help you understand that it's just predicting the next word in the sentence. And the other thing is, it's not at all intelligent. I mean, we use the word artificial intelligence, but it does not have knowledge of the world or anything. It's just what your model is, just the data which it is trained on. Okay. I'll take a pause. I mean, it's hard to imagine this, but yeah, any questions around this part?
I have one question,
Yeah.
because we saw different LLMs, right? So
Yeah.
will all the LLMs answer the same answer for a same question?
No, so they are, so one
Based on
thing,
the feed, they will respond, right?
yeah, yeah. So based on your training data, and one more statistics or one more feature of LLMs is they always give non-deterministic answers, right? So when it's that if you go in and ask one question, right, and if you ask the question again, you will not get repeatedly the same answer. It might change its tone or the sentences and all, right? Why they are non-deterministic? What it comes from is, like I said, right, it depends on the probability, right? If you see over here in my sentences, the sky is blue. In all the sentences, blue was there. Now let's say if I add one more sentence, right, which is at night,
Sky is dark.
sky is dark, right? Now it has two options when you ask this question. The
Hmm.
sky is now it has like 80% probability of answering blue and 20% probability of answering dark. So based
Mm-hmm.
on the context which you type in, right? If you type in morning sky is, then it might say blue. If you type in dark sky is, then it will put it dark. And it can hallucinate also. It can say the sky is dark also, like every time, while you might be expecting it to answer blue. So that
Mm-hmm.
is where hallucinations also come from. You might have heard this word. And
Yeah.
that is how it's probability based. I hope this makes this clear. Yeah,
Yeah.
cool. Cool. Let's move on to some the next topic, like the history. There are some technical terms when I talk about the history over here, but don't worry about them. We don't need to learn or memorize them, but it's just so that you have a holistic understanding of what was going around this space and why are LLMs powerful and all. So that's why I wanted to cover some history also. So in the machine learning space, right, before 2007, also these large language models existed through different models, not exactly large language models was the name, they were called language models. Okay. And what they did was they processed any text sequentially. Okay. And there were previous architectures called recurrent neural networks. Okay. And long and short term memory. You will also come across these two terms very frequently: RNNs, recurrent neural networks, and LSTMs, long short term memory. So what happened when they processed sentences and all, right? First thing was they were very slow and they forgot things from earlier in a sentence by the time they reach the end. So, for example, is right, I deposited money at the bank. So, when they are processing this word bank, right, they will forget all the prior context, okay, which was coming from the sentences before them, like when they were processing this particular sentence. And if you forget the prior context, you will not be able to predict correctly, right? So, that was one problem which models which existed before 2017, and they were called just language models. And this
Mm-hmm.
were the architectures used, like recurrent neural networks and long short-term memory. Okay. In June 2017, okay, a team of Google published a paper called Attention is All You Need. Okay, this is also very famous. You will get it everywhere once you type in that I want to learn about LLMs and all. First thing that you will get is this paper. This is a paper by Google published. Attention is all you need. So it introduced a concept called transformers. Okay, we'll dive deep into the architecture of the transformer. But what transformers did was they introduced a way by which you could process all these words in parallel, and you could also remember the context of the previous words, right? Why this is important that you need to remember the context of the previous words is, let's say you have these two sentences, right? I deposited money at the bank. I sat at the river bank, right? So if you look at this word bank, right, this means like a financial institution, correct? And this means a water body. So since LLMs have to be smart like humans, right? They should take in context, like we also solve this problem in this way. I can figure out that this bank is talking about a financial institution because I know the context of the previous words. Here, I can say that this is a water body because I have the context of the previous words. So this architecture, which is called transformers, introduced by Google, right? They solved this problem. Okay. So you just need to know that there is a paper published by Google, Attention is All You Need, and it introduced a concept called transformer. which could derive context from the previous words. And that is how they solved this problem. And slowly, because of this paper and this research that they came up, these large language models became very famous. Okay. So I will just take one example, a very high level example. So this is what the architecture they predicted. Okay. This is what, and we will go into each of this component. We'll dissect this, see what each of this component does, and we'll break it down in our further classes. So the whole, when we talk about the LLM architecture, right, we'll break down into each of these concepts at a conceptual level and understand. But I just want to give you a high level understanding what happens at each of the layer. So let's say you type in the sky is, right? So at the first level, what it is called is tokenization. And this paper talks about all this. Tokenization is where what it will do is it will break this sentence into individual words and assign them a number. It could be anything. We'll talk about algorithm, what converts it into a number and how does it. But for now, you can think it converted into a number, 35, 45, 65, something like that. We'll go into the mechanics. It broke it down into tokens. Okay, this is tokenization. Why tokenization? Because computers don't understand human language, right? It has to be converted into numerical form, but it intelligently converts it into a numerical form. We'll talk about tokenization. But
Will there be duplicate tokens also?
yeah,
Like,
there can be. We'll talk about it
okay.
into all of. I'm just giving you a high level architecture. It's not like I'm discussing these in detail. But when I talk about, I'll have a separate class on tokenization where because it's a deep concept also. I'm just talking at a very high conceptual level. It's a deep concept that you understand. You need to understand how is the word the just represented by the word 35. There has to be some mechanics behind it, right? We'll cover that. But this is high level thing that what it does behind the scenes. The sky is first, it will tokenize, convert it into numbers. Then it will vectorize. Okay, vectorization. You will hear this term a lot. So vectorization is also a very important concept, but now you can think of it as like from these numbers, right? They will convert it into some sort of matrices. Okay, where what it will do is it will try to capture the meaning of sky, the is, right, into some form of numbers. So each word will be converted into matrix. Okay, M1, M2, something like that. So this is called vectorization. In my demo class, I'm not sure, Manoj, if you were able to attend, but I had covered this in very much detail. I will do it again also. And vectorization is also a very important concept, but I just want to give a high level overview at like what is going on. That's why I'm not covering in deep right now. Vectorization, think of it is like you are considering it, converting them into vectors because that is what the machine understands. Now, once you are converting into vectors, right, then they said that you have to apply attention mechanism on it. Okay, what is attention? Like I said in the previous slides over here, right? To understand this thing, right? I deposited money at the bank. I sat by the river bank. How do I understand what is bank? I have to look at these previous words. I have to look at these previous words to understand the context of bank. So attention is the mechanism by which what they will do is they will convert all these words into mathematics, and then they will do some matrix multiplication and all, and figure out the previous context. Okay, this is very interesting. That how did they convert into maths and like still based on maths they could derive the meaning of the words and all. Then what will happen is they will feed it to a neural network. In next class, we'll go deep dive into neural network. But this is one concept that I want you to know that this is also a term which will come across a lot. And then from a neural network, they just predict the next sentence which should come output. Okay, which is a probability distribution. So this is like what this paper talks about on a very high level. Okay. And we will, like I said, we'll go into these details from the next class onwards. Right now, it was just to tell you that what all these components mean. Okay. And now, why is it important to understand all of this is, right? We just want to use LLMs or APIs, right? If you understand all these concepts, right? Let's say you are creating prompts today, right? You will understand that why for a certain prompt I get a better answer versus why certain prompts do not work, right? You will get better at prompting. You will understand the mechanics. It will not be a black box to you. And yeah, that's the whole point because yeah, that is what. Now, whenever, so these three terms will again are used very interchangeably in the LLM space. So which is transformer, large language models, and GPT, right? You will get confused by this term. Hey, what is the transformer? What is a large language model? What is GPT and all? Okay. So transformer is the architecture, okay, a design pattern for neural networks published by Google. It is not a product or something. You can think of it as a architecture based on which large language models are created. So transformer is the architecture. Large language model is a category of AI models that are trained on massive amounts of text using the transformer architecture. Okay. So large language models are using the transformer architecture. And what is GPT? GPT is a large language model made by the company OpenAI. Okay. So this is the end product developed by one company. LLMs are models that can be created using the transformer architecture. Maybe right now it might not make much sense, but when you read on articles on the internet or anything, you will have a clear understanding what is GPT, hey, what is large language model, what is a transformer, and all. Okay. So this was a brief history of the LLM. The main point to know is like in 2017, Google introduced this paper or did some research around uh, uh, how can language models be improved. They came up with this paper, Attention is All You Need, and the concept of transformers came in, which changed the industry entirely. Okay. So this was an history of just a brief history and what a large language model does, right? Yeah. So now let's dive into model types. This is important to understand the landscape, right? So what is a base model? Okay, we will come across these terms a lot, so that's why I want to cover this. What are base models? What are chat models? And then what are reasoning models? Okay, so there are different kinds of models. We categorize models also. So base models are nothing, but like I said, right? So I said when I covered this architecture, right? When you take the data on the web and you train a model on this data. So the capability that comes after this step is when you type in a sentence, when you type in a sentence, the sky is, it will just say blue. It will not give you the whole answer. Okay, literally, it will just tell you blue or whatever term it is. It does not knows how to answer in a question answer format. So that is called a base model. Okay. Now I take my, so that those are called base models. Now what I do is we see answers in the form of chat, right? So we take the base model and train it. We give it some data and give it question and answers. Okay, that is how it learns that I have to give answers in the form of a chat. Okay, and I will get the input in the form of a question. I have to give an output in the form of an answer. Okay, that is also called fine tuning. So we take the base model and pass some Q&A scripts and all, like some question, a doc, which multiple docs which have this format, like a question and then an answer, a question and then an answer, a question and then an answer. So now it learns that I have to respond in this particular format. So that becomes a chat model. Okay. So that becomes a chat model. Okay. So that is what chat models are. There is also a technique called reinforcement learning with human feedback. So we'll go into that, but this is what chat models, like the way I said, right? They are trained on Q&A. So there is a human feedback also required over here. So that is how base models are converted into chat models. Okay. And they are used for basically whatever chat applications we see today, right? Chat GPT, Grow, or any conversational use case, we should use chat models. Okay, like for email writing, all this creative content generation and all those things, we should use chat models. Now there is another set of models which are called reasoning models. Okay, so chat models are Q&A style. Now let's say if you have to figure out you need the LLM to answer something which requires deep reasoning, right? It's not that it will be able to, it's just a question which it can answer easily. There will be intermediary steps and it has to think through all of those, right? Think of it like a puzzle wherein you have to first come to a data point one, then from data point one to data point two, and reason everything around it, right? Like solving a math question, right? It's not like you come up with a direct answer. You have to reason through the steps, right? So reasoning models are the ones which have specialization in that. So you take the base model and then you give it system prompt, or you tell it that, okay, reason around these concepts and all, and then come up to an answer. So reasoning models have great logical thinking. Like when we are using Cursor or like any Copilot and all, they are reasoning models because they reason around stuff, right? Concepts. So they are called reasoning models. Like different models like OpenAI O3, O4 mini. These are specific models called reasoning models. There are chat models. I'll cover this further so that this concept is clear. Like what is the distinction? But you will hear a lot about these terms: base model, chat model, reasoning models. Okay, and then there are vision models, which when you give in a text, right, it produces an image. So they are called as vision models. Okay. I'll take a pause over here and just see if there are any questions. Yeah. I hope it's making sense, right? Cool.
So can chat model also behave like this reasoning model?
Yeah. So now what is happening, right? Previously, in previous, like if you would have been using GPT like from very long time, right? If you ask it like maths questions and all, right, it will not be able to answer a very. I mean, it can give wrong answers also. But now, as the time has evolved, right? How OpenAI has evolved these models, or how the models are evolving is like chat models can also, like if you just give it a prompt that reason. Like do some reasoning and then come up with the answer. Okay, it's called chain of thought. Okay, the system prompting technique is called chain of thought. So if you tell it that do this, then it will start behaving as a reasoning model as well. But the data that you train on initially, when they used to train, the data that you train a chat model on is different, and a reasoning model is also different. But right now, when you go to GPT, you will not see that there is a distinction. But yeah, let's cover more. I will come to this point. It will make clear when I tell you about one thing. Okay. In the next slides, I have that covered. It will make more sense.
Okay.
Now, there's one more term which will come across a lot, which is called multimodality in LLMs. What is multimodality? Multimodality is nothing but the capability of a model to understand different, like you give a model not only just text, but like let's say if I want to ask a model to debug an issue, right? So what I will do is I will generally give it the code snippet or the function, okay? And I can also give it like a screenshot, right? So a model which can process text plus images plus like let's say video clips or anything like which can cater to different format of data, right? Text, images, video, music, and everything are called multimodal because they have an understanding of different things. For example, text, you give prompts, documents, code. You can give images, photos, diagrams, screenshots. It can understand this plus this. It can understand audio also, speech, music, sound. If you give video, it will understand. So it was not always like this. So different models have different capabilities. If you use a text only model, if you give an image to it, right, it will say, I don't have understanding of image. If a model does not understands audio and you give an audio clip to it, it will say, I don't understand what this audio is, right? So that is what multimodality is. Again, now you won't appreciate this concept much because GPT is so powerful now that it's multimodal. It can understand everything, whatever you give. But when we use certain models in our local and all, right, or when we choose a model for our work, right? So tomorrow in office, what people can tell you is like choose a model that we can use and we'll pay for that model only because we can't use all the models, right? So that is where you need to keep into mind that I have to choose a model which is multimodal in nature, right? If your task is like generating code or troubleshooting code, multimodal LLMs are better. So you understood the concept of multimodality, right?
Yeah, actually, how the GPT or how the LLM knows that it doesn't know audio, it only
Okay.
knows text. Where is
Yeah.
that category is mentioned?
Okay, so yeah, so I'll just go to the next slide once just to quickly show you. So what all the different model providers do, right? So they provide specifically model names, right? So if you go to ChatGPT, right, ChatGPT today, you have an option to choose models. Like if you choose DALE 3, like you might have heard this term. So DALE 3, that is a specialized model which is specifically used for image generation. Now you might have also heard of Sora. This is specifically for video generation. So when you go
Mhm.
to ChatGPT or something, right, you will get this option that choose a model to get your answer. When you choose a model, then it goes in and then it changes. I will show you an example. Like in Gemini, how can I do that? It will make it more clear. Okay, let me quickly do that so that you understand or appreciate this concept. Right? First and foremost, you can see over here, there are tools, right? So if you create an image, it will use, if you might have heard of the word nano banana, right? So there is see here, there are different models. I mean, they have abstracted it out that you can use Gemini, fast version, thinking version, or pro, but there are ways by which you can choose different models also. So let me take one example over here. I hope you guys can see my screen. So this is
Yeah.
like chat G. I'm using cursor. Okay. So over here, see, I'm getting an option. Which model do I want to choose? I have an option of different models over there. Okay. So based on what I want to do, I can choose different models. So this is what the concept is. okay, of multimodal.
So that's what, if I choose a wrong model, how it can convey that to me, how it is internally understanding that this.
It will
If I
just not
chose text
understand.
model and
Like,
if I'm giving
yeah.
audio.
Yeah. So it understands by your input format, right? You are, let's say you are working on a text only model, right? So when you input the data, when it parses the input, right, it will see, hey, it is not text
Incorrect format. It will
because you
validate.
got an image. Yeah, it will validate and it will tell you, I can't answer this. Okay.
Okay.
Let me come back.
Because these days we have seen that it is generating diagrams also. So there
Yeah.
will be models for diagrams also.
Yeah. So like you can see video, right? So video models are there, image models are there. And then if you train it and tell it that, okay, that you generate image. I mean, if you think about it, diagrams, right? So diagrams are also can also be a kind of image, but if you train it, so how they do it today is they have something called as skills, or like you can integrate with third party. We'll cover this more in agents. What they do is like will just do the processing and give you the text. But what it will do is it will have an integration with a tool where it will tell you to generate that diagram or diagrams and everything. It will do that. But we'll cover this. Yeah. But I just wanted to let you know that there is categorization in the model. There is categorization in of the models. What is multimodality? Okay. Right. I covered this part. I think text plus image, text plus audio, image generation is a different model. Code plus screenshot is a different model. Okay. Now I also want to cover the classification of models from a different perspective. Okay, we hear a lot of things, right, about models. Like let's say you might have heard about GPT, right, OpenAI. Okay, you might have heard about Claude, right? You might have heard about Gemini, Grok, then Llama, DeepSeek, Quen from China, and Gemma, right? So there are plenty of models present out on the internet. They are developed by different companies. Okay, and some are called closed source models and some are called open weight models. Okay, what is closed source models? Like big companies like Google, OpenAI, what they do is when they develop the models, right, they don't give you like the weights of the model or the source code of the model. You can think about that. They only give you access to the models based on some APIs, right? Some APIs or through some chat interface, right? So they are also called frontier models. Okay. So they are called closed source models where you don't have actually the source code. You can't run those models locally. You can only run these models via chat interface or APIs. And they are like hosted by the provider itself. Like Google will host it, OpenAI will host it. You cannot run it in your company or in your infrastructure. You can call their APIs, but you can't run it, right? Whereas there is another category which is called open weight models. Okay, open weight models are some things wherein like which you can download the model and run it in your own local instance. Okay, so they are called open weight models. I'll dive deep into this. Like, what do I mean? So, like I said, right, GPT, Claude, Gemini, Grok, these are closed source models. I don't have access to their code or I can't run them locally. I'm dependent on them, on the provider to provide API or API access or chat interface access, right? Open weights are Llama, Mistral, DeepSeek, Quen. Why I'm telling you is sometimes, like, let's say we need to take a decision that which one should I choose and why should I choose that? So that is why it's important to know the distinction. Okay. So now let's look at it from an access perspective, right? Like I said, closed source models will only have API access or chat interface access, right? If I go to chat GPT, like I said, and I can use chat GPT via API, also via an API key. So these are the interfaces provided. But for open source model, I can download the model and run it from anywhere, from my local machine and also. Okay. Performance is like obviously, I mean, closed source models because they train on a lot of data, the performance is better. Open weights is like slightly less, we can say that. Cost, how is the cost decided? This is like, is pay per token. Okay, we'll understand this, what is token and tokenization. But generally, if you have to like choose a model, right, they will tell you that for 1 million tokens, you have to pay this much. Okay. So closed source models, you have to pay them, and sometimes it might be free also. But what they will do is powerful models, they will make it subscription based, wherein based on your usage, you have to pay. And some lower models, they will not charge you. So you can use it anytime. So that is about closed source. Whereas open weights model, right, you don't have to pay for anything because you just have to pay for the compute because you are running it anyway. It's like open, anybody free to use. Okay. Data privacy, from the angle of data privacy, your data hits their server. Okay, you are hitting the server of Open API, and whatever question and answer you are typing, so that data is going to their server. So you don't have control of the data. This might be like when you implement in your companies, right? This will be a very important consideration while choosing a model. While they have different ways now, you can choose their model and host it in cloud wherever you want to do it. But I just wanted to let you know from this perspective also. Like, let me take an example. Let's say if you have a code base in your company, which is very, very proprietary to your company. So what they will suggest is, don't take this code and go and type in chat GPT, right? You might have got this instructions from your HR, right? Why do they say this? Is because there are data privacy concerns. Your data will hit open API servers, right? They might store the data or something like that, and that can become a problem. So that is what it is. While open weights, you run it in your infrastructure, so there is no problem. There's no privacy concern. Okay, from a customization perspective, you can't customize much over here. Nothing can be done. Open weights, you have full control. You customize, you want to fine tune it, do it. You want to like whatever level of customization you want to do, you can do it easily. Ease of start, closed source is very easy. You just get an API key and you can start using it right away. Open weights is this is the main drawback. It will take you hours or 2 days to set up the infrastructure, choose the model, everything and all. Here, closed source, there's zero maintenance. Here, you have to do some maintenance because you are running in your infrastructure, right?
So OpenWeight allows us to give a feed to the system,
OpenWeight allows you to, sorry.
give the feeds to the system, data feed.
When you say, I mean, data feeds,
I
sorry,
think it's
can
a
you elaborate?
driving.
Yeah, what I meant is generally we give some feed to the data and try to query the things from that data only, right?
Okay, okay.
Whatever
Yeah, yeah,
input we give in
yeah,
the
yeah.
model.
Yeah, correct. So it will allow you that. You can, that is called fine tuning. So you can
Yeah.
fine tune the model based on, you can fine tune an open weight model, but not if you think we cannot fine tune chat GPT and all. Yeah. There are ways, I mean, it's a little confusing, but I mean, I'll cover that part. Don't worry. I mean, there are ways by which we can fine tune closed source models also, but RAG is one way by which you will actually help it look at your company internal database and answer, but we'll cover those parts. Yeah.
Okay.
And
That's my next question actually.
yeah,
OpenWeight can, if it can connect to our databases and the APIs get the data, but you answered in your.
so open weight models, they cannot connect to your database and stuff. What open weight models do is, like, every machine learning model has some weights, right?
Okay.
So weights are like parameters, right? You in the first slide, I talked about certain parameters, right? So what I mean by open weights model is, like, let's say tomorrow you work for a medical based company, right? And you have certain medical specific terms which the model needs to understand before answering any user question, right? So now with closed source, you cannot take the model, train it that this is my medical data, and then answer based on that. But in open weights, what you can do is, you take the model, you download it in local, you train it that, hey, this is my medical data, I will train you on that, and then you answer based on this particular data, right?
Yeah, got it.
Does it understand?
Yes, mine is also a medical company to implement on
Oh,
them. I was looking for a open weights one.
okay.
But here the thing is, like, on day-to-day databases, it's a
Mhm.
medical insurance totally. The data
Mhm.
gets changed, right? So do we need to train the module on daily basis?
No, we need to use then RAG, retrieval augmented generation. I'll
Okay.
cover that in the future classes. What
Okay.
that does is, like, you still use an LLM, but what you do is you integrate a concept wherein, like, you take your company specific data and ingest it into a vector database. Now, when LLM, you type in a question, right? It sees that, hey, I don't have context of this question. Let me look up the vector database if I can search something over there. So your company specific database will have that answer. So it will look up from there, and from there it will try to answer that. So that is the concept of RAG. I'll cover it, but for your specific use case, RAG is what is important. Yeah,
Okay.
the RAG can be done. Yeah, it is called retrieval augmented generation. You can also take a look if yeah. Okay. So now there are three primary ways. Like I said, we use models, right? One is like chat interface. I'm sure we all have seen this. Cloud APIs, right? Models will be hosted in the cloud, and then you can call the API key. You can take an API key and call those APIs and use it. And then you can download locally also. And there are tools called Hugging Face, Olama. You will hear about this term a lot, Olama. So obviously you can use this to to run them locally. Now these chat interface and cloud APIs, closed source models will only allow you this. Okay. Open source model will allow you this, okay, which is like running them locally. Now let's take an example which will clear your understanding of what I was saying previously. Like if I go to OpenAI today, right? And if I see at the model landscape, there are different kinds of models available over there. Some are called frontier models, like they are the most powerful or flagship models that OpenAI has, GPT 5.5, 5.4, and stuff like that. Then they will have image models also. How these models differ is like their training data is like when they were trained a lot on images. So they can, and also format also matters. So they can do image generation very well. So if I have to do image generation, I should use this model, DALL-E, you might have heard about it, right? Then there is video models, right? If I want to generate video for content generation, I can use this video models. Sora was one example where you can use Sora, not a general purpose model, to generate a video, right? Then there is audio model, right? If I want to generate any audio, then I should use Whisper instead of a general purpose model. And this is like, I'm just talking about OpenAI, the different kinds of model that OpenAI has, right? Now, if you're using coding, right? If you want to do a coding related task, then you can use Codex. Okay, so this is a different model from them specifically for coding. So they have trained this model on coding related tasks. So it is, when it predicts output, it will be better than a general purpose model. So that is how it is. And then there are open source models, right? Over here, what did we see is like all these, the models provided by GPT, Claude, and all, they are closed source. We cannot modify it. So what GPT chat OpenAI said is, hey, I want to give some open source models also, which people can run in their local system. So they are called open source model or OSS. Okay, you will hear these terms: GPT OSS 120 billion parameters, GPT OSS 20 billion parameters. This is an example of OpenAI. All the companies have their like, if tomorrow if you go to Gemini, it will have its own set of models. Okay, own set of models like this, specific for image, specific for audio, and all those things. You go to Grok, it will have its own set of models, and every big provider or big companies will have these models and stuff. Okay. Any questions on this part? But I think this makes a lot of concept clear, right? When we hear about different models, how are they different? We think of them only as chat models. But now you can realize this concept that how are they, I mean, what are different kinds of model available and what are they specializing on, right? And when to use which. Cool. I'll go to the next concept then. Okay, now we learned about this thing, which is open source model, a closed source model. We can use it via these things like chat API, chat interface, or like APIs which these companies itself provide. Now, how do we run the open source models or LLMs in our local machine? Like, I want to give you an hardware perspective also, that why is it hard to run LLMs, or what kind of hardware is required to run large language models on your machine. Okay, I'll just take few examples and then explain you this concept. So what happens, like we have always heard of the term CPU, right? So the problem with CPU is it only does one operation at a time. You could have multiple cores in a system, but each core can handle only one task. Okay, but these LLMs, they, like I said, right, they work on huge matrix multiplication, and the math is huge in terms of LLMs, and they have to do some parallel processing. So what happens is CPU is not the ideal place where you can run large language models. So you need to have GPU. Okay, and NVIDIA, AMD, Broadcom, all of these, they provide GPU so that you can learn. You can run large language models on them. Okay, CPU concept is clear, right? I don't need to talk about it like a lot. I think there are only few limited cores, 2 to 64 cores, typically optimized for sequential processing. Okay, best for single threaded sequential tasks. Okay, like web browsing, running operating system, and all. What is GPU? The GPU is specialized processor. Basically, it has more number of cores. Like it will have like around 5,000 to 16,000 cores, and they are specialized for like running tasks in parallel. And large language models need that. So that is why we need GPUs to run it. Now, your laptop might not have GPUs. There are different ways. We can use cloud. Cloud is the option by which like certain companies provide GPU based systems, and you can use it. And GPU is nothing but graphics processing unit. You can imagine it like in previous concept, right? If there is a gaming laptop, right, they used to have this video cards and all, right? So graphics processing unit is nothing but those graphic cards that we use. So it's a similar concept. Okay. Now I'm giving you an understanding from a hardware perspective, what hardware requirements are required for running large language models. Then there is another concept called TPU. Okay, again, see over here, Google came up with one concept that I know that large language models, I mean, Google looked at GPUs and said they are great. They were designed for games. But what if we build a chip that was ready for AI math, right? So what they said was, okay, yeah, GPU is fine. I can run my models over here and train them. But why GPU? Because that was graphics processing unit, right? Why not come up with a specific chip that is specifically for AI? Okay, so that is why they introduced TPU, tensor processing unit. Okay, they are chips which like aid the maths that LLMs do. So you can use GPU or CPU or TPUs to run the math. So from a hardware perspective, also it's clear, right? What is the difference between CPU, GPU, and TPU? You will hear these terms a lot, that we need this GPU to run this model, we need TPU to run this model, and all those things. And these companies like Nvidia, why did it become so famous after LLMs came in, right? Why is it such a major company? Because they are the ones which manufacture the chips or uh, help create GPUs. So that is why if LLM is becoming famous, if they don't have the infrastructure, you can't run those models, right? So that is why the stocks of Nvidia and all got so high after the LLMs came in, because they were providing the infra. Okay. Okay, now we understood, like, from a hardware perspective, what is CPU, GPU, and TPU. For LLMs, we need these two, GPU or TPU. Okay, now like, let's say I want to call out this concept also. Like, if you want a GPU, what you need to do is Google Colab is there, which provides you like free GPUs, which you can use to do some to run your LLMs or do some computing, whatever you want. And like I said, if you want to run a large language model in your local computer, then you have to use this tool called Olama. Okay, so they have done some optimization by which you can actually run a model which has small number of parameters in your local. Okay, and then in production, what we need is GPU access, and we use some app, a tool called VLLM to run these models. Okay. So this was like mostly around the models. Now let's deep dive. Let's go into some hands-on. Uh, that how do we? I mean, how can I create a API or something using this thing? But before that, any questions on this part, the hardware aspect, CPU, GPU, TPU?
No, I'm okay.
I'll just go into my local desktop. Okay. So yeah, let's just give me 1 second. So this is a Google Colab. So this is a Google Colab which I'm using. What it does is it helps you run Python code in a web browser. Okay, nothing more than that, and it provides you GPU access also. It's free to use. You can use it anytime. Okay. So what we will do to here is, and one more advantage over here is, you might have heard of Jupyter notebooks. So Google Colab is similar to that, wherein like you have different cells. Okay, and when we run a script or a program, right, the whole program executes at one go, right? Here, the advantage is you can type a code in one particular cell, execute and see if it works or not, then go to the next cell and see. So it's kind of you are debugging the program at every step. Okay, rather than just executing the whole program, let's say a very large program, and then figuring out that which part of the program is giving errors and stuff. And you can read a little bit about this, yeah, Google Colab or Jupyter Notebook. You'll easily understand it. Okay. So how can we make, yeah, so what I was trying to say, what we will go through this section is, let's say we have GPT, right? We'll take an example of GPT. Now, I want to use a model provided by GPT, right, in my code. So there are two ways to do that, right? One is like I can use a SDK, and the other is via REST APIs. Okay. So I will take both the examples and show you how do we do that. Okay. Now, first, I'll take an example of an SDK. So here, what over here we are doing is we are installing this package, which is called OpenAI package. Now, pip is nothing but a package manager. I mean, you might be using Java or let's say Node. So in Node, NPM is a package manager. Similarly, in Java, there might be some package manager, right? So you just need to install this particular library via pip. So I'm doing an install of that. Let me rerun this block again. So if you see, it will just reinstall this library again. Okay. And it's still running. I'll just wait for it to complete. Okay, so this is done. You can see a green tick over here. It took 13 seconds. Now what I'm doing is what you can do is like if you want to use open like you have to grab a key for using any of the models from ChatGPT, right? So what you need to do is go to chatgpt.com, and from here, this is not the place, but I'll share the link. You have to basically get an API key. Okay. For me, this is an API key that I have already generated. You need to also generate an API key for yourself. This will involve a cost like for learning purposes, right? It will be like around $5 or something. There might be some providers or like Gemini or Group, they might provide free API keys also, but I have taken this open API key, and in my environment variable, so that everybody cannot access this, I am just importing this environment variable, right? It's just a way of hiding this open API key so that when I check in my code, I don't check in this particular key, right? Now,
So are we trying to invoke an LLM API that is developed
yes.
by any open source company?
No. So this is I am trying to call like OpenAI developed GPT, right? So I'm trying to call a GPT model. I'm trying to basically call a GPT model via an API. So there are different ways. Like I'm talking about the first way, which is using SDK.
Okay.
And feel free to ask any number of questions. It's okay. Okay. And to access any particular model, right, what we need to do is we need an API key from the provider. Okay. So we need to get that by going into like GPT, like go to OpenAI keys and all, or I will share the link how to open a API key, right? You need to go in over there, log in, pay, and then get the API keys. Like if you can see this API keys section, right? I generated this API key to demonstrate. Okay. Now I have just loaded this API key. And then what I'm doing is, if you see this, I had imported this library. Okay. Now from this library, I'm telling it, create one client for me, or basically using this particular key, right? Which I got from after registering. And I'm saying that I want to use this particular model, right? GPT-4o mini in my case, because it was a cheap model, so that's why I use this. Now what I'm doing is using this library that I imported, right? OpenAI. What I'm doing is I'm creating the client and I'm using chat completions, right? I'm using this particular thing from them, which is called a method from them, which is called chat completions. Okay. So whenever you are using an SDK, there will be a documentation of the SDK. So in general, if you have to do a Q&A kind of thing, right? I use this chat completions method. Okay. And I'm creating this over here, where what I do is I pass two things: model, the model which was defined above, and messages, wherein I have to give a sequence of messages. First is role, user, content, explain me what a neural network is in exactly 3 sentences, right? So now since I'm using the SDK, right, SDK will directly call this, make this LLM call and give me the response. Okay. So let me execute this. Client is not okay. Maybe I didn't execute this. Yeah. I didn't execute this also. Okay, now this is executed. So now you see, right, the advantage. You can see this things, right? Now I have imported the OS module. I have done this. Now I'll call this. Okay, so now you can see it called the model, and the model gave me a response to this question, right? So these messages are the way in which you have to form. I mean, the way, think of it as a chat only. Whatever the model replies is called system prompt. Okay, and whatever the user or whatever question is called the user, right? So we tell it that the role is user, and this is the content, or this is the message that I'm asking. It will become more clear in the further when I go further. Okay, so you see here it explains me what a neural network is. Okay, so here I'm hitting this particular chat GPT and getting like not chat GPT, but hitting the GPT, this particular model, GPT-4o mini, and getting the response. Now let's add a system prompt, right? What does a system prompt means is like if I want to shape the response of the model. So there are different forms that a model can take, right? You can tell it that, hey, behave as a medical assistant, behave like help me behave like an interviewer. Okay, so those are system prompts which tell the user or give the context that to the system that change your answers in one particular format. Okay, so here also I'm doing the same thing. I'm calling the chat completions API, but I am telling hey, the system has this particular role, which is you are a Bollywood narrator, explain things accurately, but with drama and flair, use Hindi phrases sometimes, and with a filmy dialogue. Okay. And then the user, my question goes at the user prompt. What is a neural network? Again, the same question. So now if I run this, right, it will start answering in Hindi and with all these things. I don't know. It is non-deterministic, so I believe it answered in English itself. Hindi phrases sometimes. Okay. Yeah, here you can see. In Hindi, it started answering. So basically, you have to format, like, now you can imagine it like this also. So,
So we
like,
got the response and it interpreted the response in Hindi.
yeah. It gave you the response in Hindi itself. I mean, it's a complex. I don't want to get you
Invocation was
confused.
successful before
Yeah.
this step, right?
Yeah.
Okay.
No, invocation itself. So imagine like this. Okay. System prompt is something like this. I tell you what is the system you are, or maybe this is not a good example, but whatever I type in over here, right? Right. So this is this user role part. This is something which is given by the, like, chat GPT might have given this role itself. But if I want to change, I can tell it that, hey, do this, and it will start behaving like this itself. Okay. Let's try.
So for the API, these two roles are defined.
Yeah, no, these are like you define it, like the questions that you want to ask, right? Or your user would want to ask. So what will
So
happen is
role
I
and
will,
content are common for the API,
yeah,
for
yeah,
any API.
yeah. Role and content will be like this. Role system and content will be common. Now, let's say when I create a chat interface, right, for users, right? So whatever question they ask come in, right, we'll have to take that input and put it into role and content over here. Role as a user and content over here, right? So whatever I'm typing in over here, right, what is a neural network? Imagine that part to be coming over here. This will already be defined by you, right, as a programmer. This will become more clear. I'll go to the next example. Okay. So now see this example. I am just creating a small chat-based example, a chat. Okay. A small chat-based system wherein you see I have defined some messages. Okay. They go. So see this first message. Okay. I have a role system and I have content. You are a helpful and concise assistant, right? Then chat with an LLM, type quit to execute, right? And then I have a loop running in wherein I'll keep on taking the input, and the LLM, I'll keep appending them to this messages section with role, user, and content, whatever I type in, right? And then it will keep on giving me responses. Okay, like this, right? Chat with an LLM, type quit. So now this message is already there, right? Now when I type in what is 2 plus 2, what will happen is it in this messages section, right? With role, user, what is 2 plus 2 will go into the content part, right? And if I hit enter, now LLM will process and give you the answer, which is AI. This AI part denotes this, which is 2 plus 2 equals 4, right? And I'm doing the same thing over here. I'm calling this particular model and I'm passing all the messages to it, right? I will share the link of this collab also. You can go through it. It will be, easy to understand. What is 4 plus 4, right? So it will go in, since I'm learning a loop, it will just taking this and answer.
So where is that mathematical calculation happening in the API itself?
So the mathematical calculation, so right now what is happening is, let's forget about this. What is 2 plus 2, right? I will go into the math. I don't want to confuse you right now.
Okay.
Take this as an example. What is a neural network, right? Here there is some math. Forget about it. What is a neural network, right? I asked this question. Now let's relate back to the concepts that we learned, right? What is it doing? Predicting one word at a time, right? What is a neural network? Like this, it's generating the answer, right? So this is what is happening behind the scenes. This is the way via which you are calling it via SDK, right?
Okay. Can you type what is recurrent neural network? Then how it behaves? It will append the response to the previous response?
No, it will. Right now what I'm doing is, so these messages, what will have is they will have the history because I'm appending them, right? But what will happen is right now it will not append to it, but it will give you a whole new answer. Let's.
Okay.
So this is how, like, we'll talk more about it, but right now just
Okay. This is just how we are invoking the API.
yeah. Now this is one way via SDK, which I showed you, right? Now there is another way, which is like request and response. You all might have worked on it, right? You create
Yes.
a request, HTTP request, and then get the response. So over there, what I'm telling is this is provided by GPT to me that call this API. Okay, this is the API. This is the authorization header where again I have to pass the API key because this is my authentication key. You can think of it like that. And then in the body, I pass this that I want to use this particular model, and I pass the messages in the same format. Role, user, content, explain what a neural network in exactly 3 sentences. It will hit this API, get me the JSON response, and print the messages. Print, like when I get the data, right, it will have choices, message, content, like this. So this is a way of calling it via this thing, via API. So we learned the SDK method and the API method. Now, if you want to actually visualize, okay, we'll wait for the response. Okay, till it responds, right, I will tell you one more thing, which is the SDK, which is like we are used to this method, right? We create basically scripts, and like in company, we do it like this only, right? So what I have done over here is I have created a Python script where I have imported the modules, put the API key, what is the model I want to use and all those things. And this is the SDK method, same thing. And this is the request method.